Hello and welcome to my channel Flexomaster. Today we are going to study Anilox roles, the importance in flexography. So we start with the subject. Let's go. Anilox roles, importance in flexography. Chapter number 10. The introduction. The Anilox role is what sets the flexographic industry apart from other printing disciplines. In gravure, the image cylinder makes contact directly with the ink. In offset and letterpress, ink is transferred via smooth rollers to the printing plates. Flexography differs from these processes in that the ink is transferred to the Anilox roll, whose unusual surface determines how much ink will be deposited on the printing plate. From its beginning a half-century ago as a less than refined printing process, flexography has soared into the upper reaches of quality spectrum. The continuing development of the Anilox roll plays no small part in this achievement of excellence. Several generations of Anilox roll have emerged. For many years, the standard was the mechanical engraved chrome cylinder. They are still around, still being made somewhere in the world. But in the wide web, narrow web, and corrugated boxboard industry, the laser engraved ceramic roll became the standard and remains so today. What continues to change is the method of engraving the cells and the performance of the roll in concert with ink, as well as with Anilox roll cleaning technologies. The description. The Anilox engraving has three main variables. Line count, which is LPI, refers to the number of cells per inch. Engraving angle refers to the three-dimensional orientation of the cells in relation to one another. And cell volume, which is BCM, billion cubic microns, refers to the ink carrying capacity of the cell. And the fourth and often overlooked variable pertains to the condition of the engraved cells. The cell structure. Engraving of ceramic Anilox roll by laser is performed by using a CO2 gas laser process. A few years ago, a different technology emerged, known familiarly as YAG laser engraving. The official name is ND-YAG, an abbreviation for neodymium yttrium aluminium garnet. What separates YAG engraving from CO2 process that YAG makes use of a crystal instead of gas. This results in a laser beam with a uniform distribution of atoms in a regular arrangement. The beam wavelength is one-tenth that of the CO2 lasers, and it produced with a sharper burst of energy. The result is more complete absorption by the ceramic. The effect is more like drilling instead of blasting, and authorities says that the resulting cell walls are more uniform in size, depth, and shapes. Here I am showing you the illustration, the figure for different engraving angles. In order to discuss engraving angle, it will be necessary to receive an overview about the available engraving angles. The simplest form for engraving is represented by the 90-degree angle. Pyramidal cells are put in one row around the circumference of the cylinder. After the end of the first engraving row, the second row will be engraved, besides shifted by one cell size. The result is a 90-degree engraving in relation to the cylinder axis as it is illustrated in the drawing diagram. All right, here. The modification of 90-degree angle is the 45-degree angle to the cylinder axis. As well as you see square pyramidal cells, but the square is turned into the tip. Due to this, second engraving row needs to be positioned into the gaps. In comparison of to the 90-degree angle, the 45-degree angle offers significant mechanical advantages and has gained acceptance over a decades of printing practices. In position to the square-shaped cells, there exists a further possibility with 6 flanks, which is usually called hexagonal structure. First, the 30-degree here angle will be discussed. This angle is also situated flat top to the cylinder axis. A comparison to the 60-degree angle reveals the difference, being also hexagonal figure with 6 edges. This angle is as well situated on top to the cylinder axis. These 4 angles which we have discussed are only possible geometries which can be placed uniformly and without gaps on one area, and therefore the only ones which are suitable to use for engraving, Anilox engraving. The summary: due to the mechanical and printing reasons, the angle of 90-degree and 30-degree cannot be recommended. Therefore, suggestion is to avoid the use. Recommended angles are 45-degree and 60-degree. Because of the mechanical advantage of the 45-degree angle, which are significantly influenced by the development of flexo color separation and the plate making, a color separation of 7.5 degree and 37.5 degree and 67.5 degree plus 82.5 degree is based on the assumption the Anilox roller angle is at 45 degree engraved. Further printing advantage appear whilst using the 60-degree Anilox angle. In comparison to square-shaped cells, the hexagonal cell shape has a higher packing in rate. In other words, the hexagonal cells offers 12% more cells on the same area, as it is the job of the Anilox roller to transfer as much ink as possible and as uniform as possible. It is obvious that a higher quantity of cells indicate a plus concerning the ink transfer as well as in the terms of uniformity. Release volume. The term volume certainly one of the most often discussed items in connection with the thought, that is classifying an Anilox roller. In order to discuss this subject, it seems to be appropriate to demonstrate how volume can be achieved in a engraving in general. Therefore, it is suitable to start with a type of Anilox roller which is known to us for decades, the chrome roller. Before chrome plating the surface, the cells are embossed into the copper surface utilizing a graver. This graver is a diamond tool, has the pyramid shape. We can differentiate between 3 types of pyramid cell shapes. First, regular pyramid. As shown in the sketch aside, the graver has a regular sharp pyramid shape, and if this cell is completely filled with ink, one can easily imagine that this cell does not release the ink completely. Depend on surface tension, viscosity, and similar aspects. There will be always a residue of ink in the bottom of the cell. This is danger. The rest of the inks dries up in the cell bottom in course of time, and that printing problems that an irregular printout are caused by this. Dull pyramid. Dull pyramid is disadvantages of sharp pyramids have been noticed at a very early stage, and an improvement was created by the introduction of the flattened pyramid. The depth reduced by the cut of the top does not have any effect on the transferred regular released ink amount. The cell is rinsed better and accordingly more stable conditions with reference to the printing are achieved. The third one is dull pyramid straight cut. In order to receive a higher volume with keeping the same screen count and engraving depth, the cell are to be engraved with a sharper flank angle. As one receive a wider cell bottom, in addition, the release properties are improved significantly. A high volume is combined with an optimized ink release. And this can be done through electronic engraving by a diamond graver. Such cell shape with an optimized volume cannot be achieved by a milled Anilox roller. Now we compare this cell geometry proven for a long time to the laser engraved Anilox rollers of today use. We can easily recognize parallels. Now come to sharp cell. This laser engraving, which is surely the simplest kind, bears similar problems and difficulties as the sharp regular pyramid does. This is no complete release of the ink. Ink stains and dirt on the analogs are the result of this, which will lead to the non-uniform ink transfer. Normal cell. This is an improved cell release can be achieved in creating by a blunt calotte. Comparing both the sketches, it became plainly visible that an extreme depth which aimed at a supposed higher volume more likely leads to a sharp calotte with ink release problems. U-shaped cells. In order to receive a better ink release, it is necessary to achieve to a straight flank and a wider cell bottom. So we will continue chapter number 11 for the same subject, analogs roles importance in flexography. And I thank you very much for watching this video, and you can expect more videos in the coming time. And I wish you to comment, subscribe, like our channel. Thank you very much. See you soon.